Hello, fellow explorers of math and science. I'm Dr. Christian Macedonia, and I'd like to introduce you to a computer model I recently developed to accompany my article in IEEE Computer. This model was designed to help people experience Kosmoplex theory, to see it, interact with it, and to understand how deceptively simple and yet how deeply mathematical this system actually is. So what is the Kosmoplex? Well, it's a model of the universe that is a self-calculating system, and it comes from two Greek words, cosmos and pleiko, meaning a universe in harmony that is woven. It's triadic and closed and complete, and it's a dynamic entity, so it has no beginning or end. It's constrained by mathematics, and it iterates over time, invariant time that we call t-kairos. It's constrained by axiomatic mathematics, and it not only works under an 8-dimensional manifold, but the mathematics and axioms produce 42 entities that we call glyphs, and these are the calculating and memory elements of reality. We're in the model. This is the Kosmoplex model version 1, and I've got it set up with a lot of the action already going on. This is not the view the user will immediately see, but this is sort of some of the cool features of it. I'll revert back to the baseline in a second, but just wanted to show you some of the beauty of the model when it's really in full working form. So we'll go back to baseline, and I'll talk about some of the controls here. So we're going to reset to 0, set it back pretty much to baseline the way you would see it when you open the application. So just a few things about the menus. Obviously the title up here, you're always going to be met with a spinning globe. This is a dynamic model, so it's showing you the cycling of time that we call t-kairos. This is an information box just to show you some things about the model that you can read at your leisure. We're going to close that. If I click universal projection, what it'll do is give you an understanding of how the model mathematically can project an 8-dimensional reality down to 4 dimensions and then back again from 4 dimensions to 8. This is all the math behind that. So we'll get rid of that. I'll skip over this for a second. The model itself is scalable, so you can zoom in, you can zoom out, and you can slew it in a number of ways. You can pitch it forward or pitch it backward, and you can spin it. And of course it will automatically rotate, as we talked about with the equator, and we saw the meridian just a second ago, and here it comes around again. So then some of the more detailed menus include a listing of all 42 glyphs, and Kosmoplex theory is based on the creation of these glyphs. We'll go over that in a second. Here's a glyph table. If I click that button, this shows you all 42 glyphs, how they're created, basically their coordinate system, and as you can see, the 42 glyphs include virtually all the most important numbers in all of physics, and there's a reason behind that. I want to emphasize again, I didn't select these numbers, the mathematics does, and it selects them in this exact order, beginning with the number 1, moving through transcendentals, algebraic roots, logarithmic roots, or logarithms, trigonometric numbers, special functions, and then the boundary numbers, finishing off at glyph 42, which is the number 137. And then over here we see their actual values accompanied by their 8-dimensional value and their 4-dimensional value, and a quick note about what these numbers mean in physics. So I'll close that. Again, you can scroll down through each one of these glyphs. These allow you to select the glyph inside the spinning globe. This function over here allows you to explore the physics of the model. So the model physics is very simple. We've got an S7 sphere, so that's, imagine that being a glass sphere that contains glyphs that then operate under a very simple rule, which is essentially like the inverse square law, F1 plus F2 equals 0. So balls are repelled. I'm going to add 3 balls, and you can see that the 3 balls repel each other, go to their individual corners, if you will, on this equator. If I add another tranche of balls, and you always add 3, so 3 balls, it's a triadic universe that it's modeling, so another 3 balls go in, and we get an octahedral configuration because that's what the physics of the system produces. I do want to emphasize that it's a spinning system. If it didn't spin, there would be some other configurations we'd see, but the configurations that we see are because the globe that they're contained in actually has an axis of rotation. If I add the third set, we get a very special structure. We get a heptagon, so a 7-sided figure with then the 2 balls at the poles. And that's a very important move because if I click this button, I can show you inside this is the Fano plane. And this is important because from the Fano plane geometry, the 42 glyphs are then, we can begin to see the inklings of why the number 42 jumps out. And anybody who knows anything about this structure in the Fano plane, Fano invented this in, what, 1915, 1917, but anyway, the features of the Fano plane are well known to people in geometric algebra. It's made up of little mini 3-part components. You can see that these are labeled E0 through E6, and each of these triangles can then be configured in 2 different directions, and then we can have a different starting point by each ball, and if you multiply that by all the combinations, you get 42. That's very important because we do end up with 42 glyphs, and that's essentially how they're calculated. It would take me about 40 hours to explain everything. There's a lot explained in some of these pop-up boxes for you, or you should just read my books, and you can get into all the detailed mathematics you want, but this is a visualization tool to help people visualize what's going on inside the Kosmoplex framework. So I'm going to click off this Fano plane explanation box, and we can, if you keep your eye down on this stability meter, you'll notice that as we add glyphs, the stability will change both up and down depending on the number of balls. When it's in an unstable state, we can imagine that the balls tessellate. That would be a little bit too disconcerting for a lot of people, so I put them in the most stable position they're going to attain. But when they're in very unstable positions, we're getting more stable here for a second, but it'll go back to being unstable as I add more tranches of balls. If these were completely unconstrained at the moment, they would vibrate back and forth and jockey for position. I can also remove balls and go to different configurations, or I can go up to different levels. And you notice how when we hit 21, it got much more stable than before. We're going to keep putting more tranches of balls until we get to this level, which is level 42, and you notice something very interesting happens. When you put 42 balls under that simple constraint of F1 plus F2 equals 0, the balls will arrange themselves in this very interesting structure. And they do that by the physics of the engine. They don't do that because I've selected them to do that. So I can also, by the way, I can watch me remove some balls, and then I can go instantly to the 42 ball Kosmoplex configuration. So now it's back up to 42. I put that button in just because so much of the actions happens at this level. So we'll go here. And if you notice now the box down here, which is where we load the tranches of balls, oh, and I forgot to mention that we have a reset button there, so we can completely eliminate all the balls, but we're going to go back up to 42. So I can show all the various balls by their what I call K number, which is simply their sequence number in the listing of glyphs. And again, the glyphs will always assume these numerical positions. And again, I didn't assign those. That happens to be the sequence that they appear in the spiner that generates them. So that the number one is always going to be in the number one position, and so for instance, pi will always be in the number 12 position. It just is, and you'll have to again go into some of my books and the mathematics of it to see why these always attain those positions. But I'm going to click the labels off for a second. If I click show glyph, then anytime I click a glyph, let's say we do pi here for a second, it'll show you where pi is within the model, and it's also going to explain everything there is about how glyph number 12 or pi is generated. It'll show you the physical location in 3 space, its azimuth, so on, and it shows you exactly how it calculated that value, and there it is. Now, interestingly enough, the value that's calculated is an 8-dimensional value because this is all taking place in 8D. Again, if I want to know what the 4D value is, let's go to the glyph table and we'll go to K12, which is pi. We can see that it's calculated this way, but if we project it, it actually changes ever so slightly, and the projection is explained under this purple button right here, which actually does a little animation, and it shows you, in this case, it's showing you the glyph number 42, which is the fine structure constant, and this is the formula for projection. So anything projected down to 4D has to actually undergo a projection conversion, somewhat like a Fourier transform. Okay, so you were able to see the individual glyph calculations within each glyph, but this is the universal transformation, the universal glyph calculation formula from the numbers, the alpha number, rho, and sigma. So the next feature I'm going to show you is Yang-Baxter weaving. So Yang-Baxter weaving is very important in Kosmoplex theory because, you know, the word Kosmoplex means cosmic weave from the Greek, my ancestors, and this shows you the relationships between all glyphs and each other glyphs, and it shows it to you graphically. I think it's one of the most beautiful features of the model itself. I'm going to click that off for a second just to clarify what we're seeing. We can also, if people are interested in seeing the relationships of glyphs to other glyphs, let's say I want to see where all the integer glyphs are, I can click each one of them. If I go to select multiple glyphs, I can go 1, 2, 3, 4, 7, 8, which is the first 6 glyphs. And I can see their relationship to each other. You notice it's kind of got a sinusoidal pattern to it that's on purpose. Not my purpose, but apparently the Kosmoplex feels like that's a relationship that needs to be embedded in the system. I can also unclick these and I can go to the first number in each set and also see a different kind of relationship comes up. I'll do that all the way out to the boundary numbers, and you notice how they are all equatorial and all separated in exactly the same space. So there's a lot of interesting features of the globe that I have to say honestly, even though I was the originator of the theory, I keep finding new things inside my own model. So I'm going to clear all these. We're going to exit the multi-select mode. The last button here I want to explain is the axioms. So to be clear, if you want to understand the physics of the system, click on this axioms button and it'll explain that the system is really constrained by a simple set of constraints. It's constrained by the piano axioms, okay, the axioms that we use in all of arithmetic. But Giuseppe Piano left out two, I think, very important axioms, and that's because he was dealing with static systems. Cosmoplex is a dynamic system, so he left out a closure rule. He actually played around with the idea of a closure rule, but he never included it. And then the axiom of total function, or the axiom of completion, that all calculations have to be complete. Why those are in place is because this is a tip of the hat to David Hilbert. Well, David Hilbert was looking for a system of mathematics that explained all of physics. And you can't have a physical mathematics that can't complete itself. So if you're going to have a system of mathematics that fulfills all of David Hilbert's requirements under his famous 1900 project and his questions, if you're going to have something that is that's non-Gödelian, it's complete, then you have to invoke these rules. And if you invoke these axioms, then you do end up with a system that satisfies Hilbert's famous question number 6. So I'm going to close that. So I really appreciate anybody's input on the model. I'm putting this out there for comment, and I hope you enjoy working with it and discover new things the same way I have. So here are some helpful links. You'll see the QR code in the upper right. That's going to take you directly to the Kosmoplex globe model that I just showed you. There's also a link to the Codex Kosmoplex, which is available on Amazon and other booksellers like Barnes & Noble. And then there's the DOI for the Kosmoplex Primer, which is a deep dive into the mathematics of Kosmoplex theory. For their attention on this movie, and if you have any comments, please drop me a line, and have a beautiful rest of your day.